chapter of, let us see. Oh, sorry, my camera is, it's a zooming camera, so I can, okay, I think you can see it clearly now. So in this chapter we are going to learn instructions, C instructions. Okay. Okay, a program is nothing but a set of instructions. Different instructions help us achieve different tasks in program. In this chapter we are going to see how to write simple C programs by using different instructions. So there are three type of instructions in C. Type declaration instruction. So this type of instruction is used. Okay, let me clear it out. Okay, here it is. This instruction is used to declare the type of variable used in C program. Arithmetic instruction used to perform arithmetic operations on constants and variables. Control instruction is used to control the sequence of execution of various statements in C program. Okay, so type declaration instruction. So this instruction is used to declare the type of variables being used. Okay, the type of declaration instruction is written at the beginning of main function. Okay, a few examples are shown here. The type of declaration instruction is written in the beginning, like int uh, int bash, float rs, grossal, char name code. Here are a few sub, subtle variations of these type of declarations while declaring the type of it. We can also initialize it. Okay, while see this after int, yeah. So after int I is equal to 10, we are also initializing it. Okay, while declaring the type is int, we are declaring it as int. Okay, so we can also initialize it, like we can say I is equal to 10, j is equal to 25. Float is declaration, and we are initializing it over here. A is equal to, either we can write it as, we can also do it like this. We can also do it like this, int ij. So when we write int ij, so we are not initializing it, but when we say int I is equal to 10 and j is equal to 5, so we have initialized it over here. Okay, so a variable must then defined before using it, the following statement. Okay, so whatever the variable is, like over here, okay, so it must be defined, like b is equal to a plus 3.1 comma a is equal to 1.5. Following statement works. Okay, so today we are going to complete the chapter within 30 minutes because we have no time for this. Okay, int a b c d. Now in the next line we are writing a is equal to b is equal to c is equal to 10. Each variable would be assigned a value of 10. However, the following statement would not work. Int a is equal to b is equal to c is equal to d is equal to 10. This thing doesn't work. This is wrong way. This is the correct way. Int, we have declared it that A, B, C, D is integer, and over here we are declaring it as A is equal to B is equal to C is equal to 10. Okay. The error is we are trying to use B to assign A before defining it. We haven't defined it over over here. We haven't defined it. Okay. If we try to directly do this thing, int A is equal to B, this is wrong way. Okay. Okay. Arithmetic instructions. Okay, so arithmetic instruction in C consists of variable on the left hand of is equal to, like, on this thing. Arithmetic in C consists of variable name on the left hand of equal to and variable name and constant connected using operators on the right hand of equal to. Int AD, float, cot, data, alpha, beta, gamma. AD is equal to 3200, cot is equal to 0.0056, data is equal to alpha multiply beta divided by gamma plus 3.2 multiply 2 divided by 5. These are arithmetic operations. What what is arithmetic operation? Multiply, divide, minus, plus are arithmetic operators. Okay. Equal to is assignment operator. Okay. These are integer constants 2, 5, 3200, and the 3.2 and 0.0056 is a real constant. AD is integer variable. AD is the value. Okay. So power that are variables. Okay. These are following the power variable. Okay. Variable and constant together are called operands on which the work is being done. It is operand. While executing an arithmetic statement, the operand on the right side are operated upon by arithmetic operator, and the rest is assigned using assignment operator. Integer mode arithmetic statement. In statement, all operands are either integer variables or integer constants. Int I arithmetic statement. In statement, all operands are either integer variable or integer constants. King is equal to Isaac multiply 234 plus no 8 minus 7689. Okay. Real mode arithmetic. Okay. Integer mode. It was integer mode. This is okay. Float. Okay. In which both are given mixed. C allows only variables on left hand side of equal to, that is z is equal to k multiply l is legal, whereas k multiply l. Okay, so in this language we have to define before, like we can define v is equal to 2 into jk. We cannot say like 2 is 2 into jk is equal to v. This is wrong, this is right. Okay, this is correct way, this is wrong way. So on the left hand side, a variable is written and it is defined over here, not like this. You cannot define and then write it. Modular division operator. The operator returns the remainder on the dividing. The expression turned to real figure 0. Okay. If this Okay, for arithmetic operations, if this sign is being given over somewhere, this sign, so if 10 upon 2 is equal to 5, okay, this value will come. But if 10 is remain modular division, in modular division this answer is 0. Okay, because in arithmetic operation it is either 0 or 1. 0 or 1 is yielded. It cannot be used, this modular operator cannot be used with floats. And always the sign of numerator is given to the answer. Okay, if 5 cannot be used with floats. Also note that on using this modular operator, sign remains always the same as the sign of numerator. Thus minus 5 modular operator 2 yields minus 1. Okay, this thing is remainder. Okay, arithmetic operations can be performed on int, float, cars. Thus the following statements are valid. Car x is equal to a, y is equal to b, z is equal to x plus y. A, B, R. For A, the code is 011000001 and 001100010. Their decimal equivalent is 97 and 98. The addition is performed on these decimal value, not on the characters themselves. No operator is assumed to be present. It must be written explicitly. A is equal to C dot B. Okay. Dot C. In this thing, A dot B dot C doesn't mean multiply. You have to specifically write it like this: A dot B dot C. Then it will become understood by C language. Okay. There is no operator in C to perform exponentiation operation. Exponentiation has to be carried as pow by pow. If there are exponents, it can be expressed as POW 3.2, 2.0, printf. POW function is standard library function. It is being used to raise 3 to the power of 2. POW function works only with real numbers, hence we use 3.0 and 2.0. Note that POW to work, it is necessary to include math.h. It is a library. Math.h is a library. We have to use it. Okay, so we'll have to previously define it while using the program. There are more functions like ABS, SQRT, sine, cos, tan, etc. declared in math.h on your own. Okay. Integer and float conversion. An arithmetic operation between integer and integer always yields an integer. Operation between real and real always results real. Operation between integer and real always yield a real result. Okay, in operation the integer is first promoted to a real and then operation is performed. Okay, hence the value is real. Okay, here are the examples. See, both are integers, so result is integer. Okay, one is real, another is integer. Result is real, integer, real, and the result is real. Real, real, result is real. Integer, integer, result is 0. Okay, so now you understand it. Type conversion in assignment. Okay, if type of expression on RHS and LHS of equal to are not same, then the value of expression on RHS is promoted or demoted depending on the type of variable on the left hand side of equal to. For example, consider the following assignments. Int I, float b. I is equal to 3.5, b is equal to 30. Here, though 3.5 is float, it cannot be stored in I since it is an integer. Okay, so we have defined int I. So we have defined I as integer, but here we are writing it as 3.5. So it is promoted or either demoted. Okay, hence float 3.5 float is demoted to 3 because it has to be integer because we have defined it as an integer over here. So it is demoted. Opposite happens in the next statement. Here 30 is promoted to 30.0 and then stored in B because we have stated that B is a float. So 30.0 we have to type, I mean to say computer will automatically take it as 30.0 because we have defined it as a float. Instead of simple expression used above, if complex expression is used, still the same rule apply. Some operands are int whereas others are float. As you know, during evaluation of the expression, the ints would be promoted to floats and the result of the expression will be float. But when the float value is assigned to s, it again demoted to integer then stored in s. When in, how long is this chapter? One more page and the chapter is complete. We are going to sleep after that. Okay, arithmetic instructions is k equal to 2 divided by 9 and result is 0 because it is arithmetic, so we only want the answers in zeros and ones. Okay, 2 divided by 9, answer is 0 and result would be 0.0. Here k is integer variable and a is real variable. K is integer and a is real variable. Okay, 9 divided by 2 is 4.5, but it is demoted to 4. Okay, it is demoted to 4 because k is integer variable, but here again same thing happens over here. A is equal to 9 divided by 2. Okay, so 4.5 to 4.5 and result is 4 because both are written as integer variable, so it is demoted. But when it is written as integer, it is demoted, and when it is written as real integer, it is promoted. Hierarchy. Okay, so here is the hierarchy I told you yesterday how it happens. This this is the priority of arithmetic operations. See, first of priority is given to multiplication, then division, then modular division. Okay, in if these three are present, then priority is given to this one, multiplication first, then division, then modular division, then addition, then subtraction, then equal to assignment. So murderous, murderous. I take it as a remainder. Okay, murderous. In this way, you will easily learn this thing. If you write it as MDRAS, murderous, multiplication, division, remainder, that is modular division, okay, addition and subtraction. So it is easy to remember how the hierarchy happens. Now we have some examples over here, and the chapter is complete. No, one more page to go. Okay. Determine the hierarchy operation. Evaluate the following expression assuming I is in an integer variable. This is an integer variable, so the answer would not be in points. It would be straightforward, either demoted or promoted. Okay, mainly demoted. So madras. So m here. Okay, 2 into 3 6. Okay, 6 divided by 4 plus 4 divided by 4 plus 8 minus 2 plus 5. So this is the here it is. 2 into 3 6. First it did the 6 and then division. So division will happen over here. 4 6 divided by 4, 4 divided by 4, 8 divided 5 divided by 8. So next step would be this one. So 6 divided by 4. So 1 point something. Okay. So first this thing and then divide the same thing. 6 divided by 4, answer yields 1. We don't go into dots because I is an integer, so we demote it to 1. 4 divided 4 1 plus 1 plus 4 divided by 4, this, and then again division. This thing divide 4 divided by 4, 1 1 1, 8 minus 2 plus 5 divided by 8. Again division over here, 5 0. Okay, 1 plus 1 plus 8 minus 2. Madras. Addition. Then we go for addition. 1 2 plus 8. 1 2. So a 1 plus 1 2, 8 minus 2 plus 0. 10 minus 2 plus 0. 8 plus 0, 8. Answer is 8. Okay. So here k is a float number. So in this example, k is a float number. So again, it is promoted or demoted as per. Determine the hierarchy of operation. Evaluate the following. Assuming k is a float number. Madras m 2 into 4 8. So m. Okay. 2 2 divided by 3. Okay. What it is doing? Why it is doing this thing? First it should multiply. Sorry, divide. First it will divide. Then it should go up. 3 divided by 8 gives 0. Again for the same reason mentioned in the field. Okay. 3 divided by 8, 0. A is float. 3 2 1. 1 multiply 4 plus 3 divided by 8, 0. Okay. size 0. I don't know what is. Let's go for next thing. Algebraic expression. So we will experience here evaluate regional some example is algebraic evaluation. Yeah. So C expression is not directly like this. It has to be written like A multiply this and then minus C multiply this. The same expression is over here. M plus N A when A so here we have to define that there is multiplication over here, right? So 3x the power 2. So we have to write 3x into x plus 2x 2 into x plus 5. So every time you have to define it with a symbol over there. Okay. Associative operators. When an expression contains two operators of equal polarity, the tie between the same is settled using associative operator. All operators in C either have left to right associative or right to left associativity. Let us understand this with the help of few examples. Consider the expression A is equal to 3 divided by 2 multiplied 5. Here the tie operator is same, that is between divide and multiply. The tie is settled out using associative of divide and multiply. Both enjoy left to right associative. Therefore, first operation is done followed by multiplication. Firstly, you do the division and then see Madras. That's why I told you Madras over here. Mul multiplication is first, division is the second. So we have the same priority as same as left to right. To right, okay, left to right. In this such case, combine is free to perform as per its convenience, since no matter which is performed earlier, the result would be the same. So you can do, you can choose which one you want to do between these three: multiplication, division, and modular division, and between these two as well. Okay, but you cannot do this addition and subtraction before multiplication division. Okay. Control instruction control the order in which instruction program get executed. In other words, the control instruction determine the flow of control. There are four types of sequence control instructions: selection or decision control instruction, repetition or loop instruction, case control instruction. The sequence control instruction ensure that the instructions are executed in the same order in which appear in the program. Decision and case control instruction allow the computer to take decision as to which instruction is to be executed next. The loop controls instruction help execute a group of statements repeatedly. In the following chapters, we are going to discuss it further. Okay, so for today, I think the chapter is completed. So tomorrow we will be doing the chapter number 3, decision control instructions, and I hope we will learn it from tomorrow on. Okay, the heat is going to be raised. I wish you all the best. Take care. Ta-ra for today. Our chapter is done, and see ya. Nay.